钟代江老师 ，Let's welcome. And the second one is 台师大陈宏仪老师。The third jury is 台湾科学教育馆朱万生老师。And the fourth jury is 阳明交大林俊良老师。Welcome. And next, I would like to ask the team leader of the reporter to introduce your members. I'd like to know your team member's name, the grade, and what is your favorite topics in physics. 3 points. Name, grade. What is your favorite topic in physics? Okay, reporter from Zhang Huanzhong.
Hello everyone, we're Tina Zhongya, and I'm from National Zhang High School, and I'm the leader of the team. My name is Chen Yuan, and these are my teammates. She is Chen Liqing, and she is Lin Pingxi, and she is Dai Chengxi, and she is Cai Lian.
And your grade?
And my grades are...
Your second year or third year or first year?
I'm second year.
Second year, how about your team member?
And she is first year, and she is second year, and she is second year, and she is...
Okay, so it's a combination of the first year and second year. What is your favorite topics in physics?
My third topic is magnetic.
Magnetism. And how about your team member?
Fluid.
Fluid dynamics. What else?
She is sound and she is also magnetism.
Oh, all magnetism. Okay, thank you very much. Okay, let's welcome. And your opponent is from Kaohsiung Yuzhong. Could you introduce your team member's name and grade and describe their favorite topics in physics?
Okay, hello everyone. We are the level 2 from KGHS. I'm the team leader. And this is Huang Luojia, this is Wu Yizhen, this is Yang Yaojun, this is Hui Yujing. And me, I am Huang Luojia, and Wu Yizhen and Yang Yaojun are all in first grade. And except for Hui Yujing, she's in second grade. And the favorite business topic, our favorite business topic is chaos, because we think it is a great discovery.
Chaos. Oh,
Yeah.
very challenging topic. You're all interested in chaos.
Yeah.
Wow. It's interesting. Chaos. Thank you, thank you. Let's welcome. And the reviewer from Kaohsiung Zhongxue.
Okay, so hi everyone, I'm the team leader from our primary and we're from Kaohsiung Senior High School. And my name is Wei Zhen Huang, and he is Liu Jiachen, and he is Chen Jianchang, he is Yang Liyue, he is Lan Bojun. And both of, except me, they're all grade 1 and grade 2.
Okay.
And both of us, we would like to analyze the force between the phenomena in the physics.
Force.
Yeah.
Oh, okay. Force. That's great. Thank you. Now we go round 1. The opponent challenged the reporter for the project.
I would like to challenge the 15 volleyball.
Sorry.
15 volleyball.
Okay, number problem 15.
Yeah.
Number 15. Okay, Walling board. So the reporter accept or reject the challenge. 1 minute. Please think about in 1 minute. Do you want to accept or reject the problem number 15 challenge? 5 minutes. And each team, please write down your representative name on the blackboard. 他们可能摄影机要在后面，讨论可能在那边。陈宇安。声音啊，他要放声音，这个工作人员，我们这边有没有声音的？你要播声音是不是？待会报告。我们这个投影机大概没有办法接收。你的投影机啊，这是你的笔电的声音。可以就是因为投影机应该是会。你看很小声，在旁边有些大声。没有啊，你看这个。哦，那台。还有时间吗？没有。刚我写到。要不要用你自己笔电的声音啊？比较大。直接从笔电出来，这个打字。笔电好多了，好不好？用笔电吧，知道听到当的意思，好不好 ？OK， 谢谢。因为我们这边没有麦克风，15 题。准备好可以开始了。Okay, so now the reporter ready to give a presentation. You have 12 minutes.
Hello everyone, my name is Chen Yuan from Andromeda. Today I'm going to report problem number 15, welding code. Here is the problem statement. When you strike the side of the metal ball containing some water, you can hear a characteristic sound. The sound changes when the water in the ball is moving. So the problem statement asks us to explain and investigate this phenomenon. And the following 2 points are our main focus. First one is what caused the welding sound, which means the characteristic sound in the problem statement. And number 2 is how do relevant parameters affect the sound. First of all, let's begin from the observation. Here is the different you can hear a single and flat tone. And next is the moving one. So you can hear a really big difference from this sound. So in that case, we define it as the wailing sound. And next is the sending wave. This is the comparison between a single tone and a striking pulse sound. You can see that the single tone will go flat, while the striking pulse sound will go waving. And then I'm going to talk about the ball sounding process. First, the ball will strike on the ball, and then every single point at the ball will do the simple harmonic motion, but the friction will also exert it on it, so the sound will finally stop. And after the ball strike on the ball, it will cause a lot of different frequency. But only the steady wave lasts long, while others interfere and disappear. And then is our experiment setup. As you can see that I use a pendulum to control the force strike on the ball, and I also use the directional microphone to have a better record of the sound. And then in order to control the shaking frequency, I use the metronome, and in order to control the shaking amplitude, I mark scale and also use checker to double check it. And then in our experiment, my way to shake the ball is just like this. We'll go left leaning and right leaning, and just keep going on. And then in the beginning of the data, I will introduce the static water. Here is the variable of different water value. So you can see that in this graph, the x-axis is the water value, and the y-axis is the fundamental frequency. You can see that when the water value increases, the frequency will decrease. So why it would happen? Let's start from the one dimension, a string. Here is the formula of it. And from this formula, we can know that if the length of the string increases, the frequency will decrease. And then, let's go to the two dimension, a plate. So we also can know that if the length and the width increase, the frequency will decrease. So finally, we can expand it into the three dimension, a ball. So we can know that if the length, the width, and height of it increase, the frequency will decrease. So we can know that water value increase, the frequency will decrease. And then beside the data on the last page, I also found a really interesting phenomenon called beat frequency. It may not be really clearly, but in this record, there is a non-continuous sound, which is just the beat frequency. The beat frequency is the superposition of two similar frequencies. And because that it appears in the static water, so we not define it as the wailing sound. And then is the comparison between not wailing sound and the wailing sound, and also the investigation of finding out what caused the wailing sound. So first of all, let's compare the frequency and time graph. In the upper one is the water, when the water is static. And you can see that the line of the frequency would just go straight, but when the water is moving, it will go waving. And next, let's compare the amplitude and time graph. Because that I can't find really big difference on the amplitude and time graph. So I'll say that the frequency changes is the main reason to cause the wailing sound. And then let's compare the fundamental frequency of the static water and moving water. From this graph, we can know that the frequency of the moving water is always smaller than the frequency of static water. And according to the phenomenon, I'm guessing that it's the water level difference cause the wailing sound. So I do this experiment, the tilt angle. And in this graph, the x-axis is the tilt angle, and the y-axis is the fundamental frequency. From this graph, we can know that if the tilt angle increases, the fundamental frequency will decrease. So my prediction is correct. The water level changes will cause the frequency changes and further cause the wailing sound. So finally, let's come to the main course, which is the moving water. First, let's define what is the big wailing, what is the loud wailing sound. So from this full record, we can hear really obvious that if the obvious of the wave increase, which means that the amplitude of it will also increase, and the wailing sound will also increase. And then is the first variable, the amount of water. So here is the result. In order to quantify it, I define the 200 millimeters amplitude as 1 and measure the ratio of the others. So we can get this graph. In this graph, we can know that when the water value decreases, which means that the frequency will decrease, so the energy will be bigger. So we can know that when the water value increases, the wailing sound will also increase. And the next variable is the shaking frequency. Just as the same method as the last page, I defined the 200 millimeter and 130 beats per minute as 1. And here is the data of the others. So the x-axis is the shaking frequency, and the y-axis is the ratio. So from this graph, we can know that the loudest wailing sound appears in a range of 170 to 190. So let's have an investigation of it. Here is the critical value I found in the variable. So the blue area represents that the frequency can make wailing sound, while the red area represents that the frequency cannot make wailing sound. And there are two different conditions. First one is when the shaking frequency is too low. Because before the water level changes, the energy has already disappeared, so that we can't hear an obvious wailing sound. And the second condition is when the shaking frequency is too high. Because I think that the wailing frequency cannot catch up with the frequency of the hand, so which we call black, and so there is also not obvious wailing sound. So let's have a quick summary is that the water value increase, the range of the wailing sound will also increase. And besides that, I also found a relationship between the shaking frequency and the wailing frequency. First, let's define what is the shaking frequency. So this is also the frequency and time graph, and we define it as a wave. Here's the result. So the x-axis is the shaking frequency, the y-axis is the frequency. The blue dots represent the wailing frequency, is like this, and the blue line represents the shaking frequency. And because we found that the wailing sound frequency will almost equals to the shaking frequency, so we can know it's a forced vibration. And next, let's come to the explanation for it. So first, the ball will go right leaning and will create a low pitch, right? Just as the previous slide that the tail angle increased, the frequency will decrease, right? So if we right leaning, it will cause low pitch. And then if we balance it, which means that the water level is horizontal, so it will cause the higher pitch. And finally is the left leaning. So because the tail angle is getting bigger, so the frequency will get lower. And it is just a wave as the same one. So finally, let's come to our conclusion. First part is the static water compared to the wailing sound. So if the ball is not moving, its frequency will happen. And if the ball is moving, it will cause wailing sound. And our definition of wailing sound is the formation of waves in the FT graph caused by regular frequency change. And then is the formation of wailing sound. So from my experiment, we can know that the tail angle increase, the frequency will decrease. So if we tilt and balance and tilt, the frequency will get low, high, and low. And it is just a wave, and so we can now just add the result. And finally is the factor to affect the wailing sound. So there are two variables that I have done in my presentation. First one is the water value. So we can find that the water will increase, the frequency will decrease, so energy will increase. So we can know that when the water will increase, the wailing sound will also increase. And next is the shaking frequency. We found that the water will increase, the range of the wailing sound will also increase. And we also found a really interesting relationship between the shaking frequency and the wailing frequency is that the frequency of the wailing sound is almost equals to the shaking frequency. And that's all for my presentation. Thank you.
Okay, thank you very much for your presentation. Now the question of the opponent to the reporter answered by the reporter. 2 minutes.
You say that you control the force.
Yes.
Is that right?
Yes.
And did you control the angle of the ball that related to the ball?
Yes, of course.
And did you ensure that the water in your ball remains the same?
Remain the same? What do you mean by it?
Oh, well, you say that if the water in the ball is static, yeah, it's static. And how did you know that it is static?
We'll leave it for a very long time and ensure that we have used tracker to check the water level is almost flat. So at that time we'll do the experiment.
Did you investigate the error bars in your experiment?
Yes, I have done a lot of experiments, but the result is the same, so I didn't put error.
Okay. Is that all same?
Yes.
Okay. I think I will discuss with you later. And did you have the certain data of the frequency or some kind of force?
The data for frequency?
Yeah, because it seems that you just have the picture and I don't know, is there a certain data?
Oh, I have to say that in order to quantify the wailing sound, right? So I define that as 1, so we can get a quantification of it instead of just saying.
Okay. So this is 1, and how did you define the other one? Because
Define the other one.
yeah, because this is 1, but I don't think that it's
Okay, I know what you mean.
Thank you. The time is up. So now we move to the preparation of the opponent. 3 minutes.
okay. Due to the discussion with the
Preparation. So you have 3 minutes to think about the reporter.
他们讨论在那边嘛，那个白板还是要在那边。
因为都觉得所以他们用。
你拍照什么时候？都可以。这边太远了。
opponent 右先 takes the floor. The next my opponent, please.
Okay. Oh, first started. I asked the reporter that did she cover the course. She said yes, and I think I will discuss about how she control her course to collect the ball. And she said that she defined it as one, but I don't know how she defined it, and I don't know how she know that the other one's data. And she's report is like of certain data. So I think I will ask her why she use the chart to represent her experiment. And now here's a phenomenon is set up. And this is a phenomenon of the welding ball. And I think I will highlight the contents of water, because without water it won't have the kind of various one. And the characteristic sound, and the sound will change. String, oh yeah. And she said that the string length decrease. When the string length decrease, the frequency will decrease. And place that decrease. Okay. And this is a comparison of water static. And when the water is static, it won't welding. But if the water become like moving or gets collide by something, it will become welding. And tilt angle increase. When the tilt angle increase, the frequency will increase. When the water volume increase, the F will decrease, and the energy will decrease. But there is three kind of different things to discuss in her curriculum, so I think I will ask her in a further discussion. Okay, this is the loudest sound of her experiment. Okay, this is a conclusion. Water volume increase and welding. When the water volume increase, the welding range will increase. The welding sound frequency will equal the shaking frequency. And welding sound and shake. Okay, I think that's all.
So now you want to move to the discussion?
Yes.
Okay, so please go to the discussion.
Okay, here's a discussion. I will first ask you about this. Yeah, how did you define one, and how did you know the other one?
I use tracker to check it.
Use tracker.
Yeah, because I put it into.
Okay, actually, I'm asking how did you know that this is, I know you define it as one, yes. But I don't know here, how did you know that the certain data of those
Certain data. I measured the highest point and the lowest point. The highest point.
So this is the amplitude of this.
Amplitude. It's a little bit complicated because it's the amplitude of the frequency times zero. So it's not the real amplitude of the welding sound. It just. So I define a wave here, right?
Yes.
This is the frequency and time graph. So it is a wave.
Yeah, I believe.
Yes, a wave. So I measure the highest point and the lowest point of the wave.
Yeah.
Yes.
Okay, so back to the next page. The one we discussed. But you said that this is the wave.
Yes, the wave.
But this looks like the amplitude.
On the amplitude? Yes. Yes. What
Okay,
do
turn to the next discussion. You say that error bar is
to release the ball from of the pendulum. So I think the frequency will be the same, and it's just the same as my experiment results.
So the place your ball collect the ball change.
Yeah, I'm sure.
How did you ensure that?
We just control the angle, and if you really want to know that, is that we put a ruler to make sure the position is just the same.
How did you use the ruler to ensure that? You can draw a picture for me so that I can show that to you.
For every experiment, we can use a ruler to know that the position is all the same.
Yeah, and the length between the ball and the ball.
Yes, and the gap here is the same.
Okay. So you use the kind of ways to control the force to give to the ball.
Yes.
Okay. And okay, we can go back. Okay, I'm really curious about how did you draw the kind of line?
This is not a theoretical line, it's just a trend line. So it's just to let everybody know that the trend is go up.
Oh, so there's no theory to support this.
If you theory to support that, because if you want to explain it, we can just use this. The frequency, the water balance increase, so the frequency will increase, right? Because yes, so the energy will be bigger.
So how did you get this?
Water value increase, balance sound will increase, just as the trend.
So why isn't okay? So this is the kind of can you go back to the page you have the formula?
You mean,
Oh yes. Could you explain the different symbol of major formula because I don't know what is
I think it's not really important because the reason why I put this page is that I just want to tell you the length. If the length increase, the frequency will increase, and this also the length and width increase, the frequency will increase. So if we add more water to the bowl, so means that the length and the width is fixed because the ball is the same size. It's the same size. And if we add more water into the ball, so the height will increase. So we can know that the frequency will increase. So I don't think this is important.
Oh, you just say that again because I don't know. If this is not important, why did you put it on the report?
I just want to tell you that why the length, the width, and the height increase, the frequency will increase. This is not the major. In our experiment, it's the 3-dimensional.
Yeah.
And it just, we can expand here from here.
Oh, how did you explain this from here? Because I think that here and here have two formulas to support your dot, but this lack of any support to get the kind of conclusion.
Okay, let me explain again for you. Just if we look at the 1 dimension in the screen, right?
Yeah.
So the formula here, we can know that the length increase, the frequency will increase.
Length?
The length of the strip increase.
Okay.
Right?
Yes.
Yes. And if we expand it to the 2 dimension, You can see that LX and LYS has the lower pace, the floor plate. So the length decrease, which means that this value will decrease.
Yeah.
And this decrease, this value will decrease. So if we add it together, and finally, the final conclusion is that the frequency will decrease.
Oh. So what does that mean?
I say that it's not very important because maybe we can discuss some others.
Okay. To the next. Please go to the 20. Page 20. Oh, okay. How did you measure that the shaking frequency is low, and how did you measure that it's high?
Oh, you mean? Oh, I can explain the critical value here. So I do all the data points here, and we found that in the 200 millimeters, the range that it can cause wailing sound is just here, from here to here. And we can know the water value increase, the range will also increase. And this too is just to describe the condition that for the shaking frequency, for example, if the shaking frequency is too low for 200 millimeters, maybe the 110, 90, and the lower one. And if the shaking frequency is too low, before the water level change, the energy has already disappeared, so we cannot hear the obvious noise.
Oh, okay. Does the place you place the ball collide will impact on the result in your experiment?
Can you explain
The place the ball collides to the ball
this?
will impact on your results?
I don't think it will impact the result because the system is the ball and the water, right?
Yeah.
And it will like vibration together. So the sound that it causes is single.
Vibrations. So this is your own thought, or there's any experiment to support your result?
Because they're connected together, they're not separated, so they're all vibrations together.
How did you know that they will separate?
Because the water contact the ball. We didn't separate. What do you mean by this?
It's not clear to know that. Why did it? Oh yeah. It won't be. We have to like take out the each variables to discuss this. And yeah, the question.
Thank you. The opponent summarized the discussion in 1 minute.
We talked about how she controlled the force by using the kind of ball, and she said that she used a ruler to make sure the height the ball will collide to the ball is constant, and she also remain the angle is she also make the angle of the ball to collide the ball will be the same. And she said that the amplifier won't be conducted in her experiment. Although I didn't discuss, I didn't agree with her, but I don't think that it is a right thing. And another one is that she said that this is just how she defined she used tracker to define
Thank you. Now we go to the next, the question of the reviewer to the reporter and opponent. Reporter, enough.
And I'm a reviewer from Kimberly. And the first question I want to ask the reporter, do you in your experiment you change the angle of the platform, and do you ensure that your pendulum hit the same place of the ball?
Yes.
Is that how you control it?
Just as the same method I have talked about.
But you change the angle of the platform, so you will one is axis picture.
Oh, you mean this?
Okay.
The x-axis is time and the y-axis is the frequency.
Okay, and how you track the motion of the water?
I didn't do investigation of the water. I just investigated the sound that it caused.
So you don't consider the motion of water.
What do you mean by the motion of water?
When you hit the ball and water will move it. So the
When
motion.
I hit the ball, you mean at the static state or the moving
Shaking.
state? Shaking?
Well,
Well, when I strike the ball on the ball, and we will just continually shake the ball. So I don't think it will cause a big effect on it.
okay, can you start with your equation page?
But actually, it's not an equation. It's just an explanation for the result.
Okay, and can you explain the symbol of your
Simple.
symbol?
Well, I have to say that I think it's not important because the reason why I put this page is just want to explain why the water level increased, the frequency was decreased.
Okay.
So I think the point is not at there.
Okay. And that's all my question.
Okay, thank you. Now the preparation of the reviewer, 2 minutes. Okay, the reviewer, take the floor. You have 4 minutes.
Hello, I'm the reviewer from TYPT, and I'm here to review number 15, welding ball. And the problem statement is when you strike the side of a metal ball containing some water, and you can hear a characteristic sound. And the sound change when water in the ball is moving. So explain this phenomenon and investigate the phenomenon. And about the summary of the report, we use the simple harmonic motion and friction, frequency weightage, and moving water, and welding sound. And the experiment, we use pendulum to control the force, and use microphone to record and the water volume and height angle and moving water. And about the strength of the report, we use simple physics explanation and clear picture to show the experiment, and also use the video to show the welding sound. And he has clear modeling to explain the problem and his creative experimental setup. And also, as section said, it didn't match the experiment with the data, and also she can show more video to see how the setup, and also the data analysis of the axis or meaning in her picture meaning is not very clear, and also the definition of symbol and his And about the strength of component, we understand problem statement well and asking data correct meaning, and also consider other conditions, and he acts detailed in the experience setup. And also his suggestion is that he should add more about the theory to his experiment and the data. And he can compare the theory with the data and focus on setup and also the frequency change in different parameters. And I think in their discussion, the missed point is the feature of material bulk and moving wave of water and quantitative theory and data correct meaning, and that is mentioned in the question. Okay, so the discussion of theory, one is are there theory to improve the frequency, and the reporter say energy will bigger, and I think they can compare with the theory line. And second is length meaning in report, and the report says string. I think it can show the breadth or the picture. And third is vibration, and the reporter say the vibration it will vibration together, and I think it can clarify the explanation. And about the experiment, the opponent asks how he control the angle of the pendulum, and the reporter say it's at the same angle. I think he can show the video. And the second is hitting angle, and also the reporter say use pendulum to control the hit angle, and I think he could also show the video. My question, the first is what is the material of ball? And the reporter said he used metal ball, but I think he should consider the medium because the energy will pass over, and also how the sound of passing will also affect by the material. And second is, do you hit the same place in the type angle experiment? And he said he hit the edge of the ball, but I think he should consider more because if he change the angle or shape, maybe the pendulum will not hit the same place of the ball. And third is symbol meaning, and he said he is not very important, so I think she can explain more about his equations more detailed, and that's all my review.
Okay, thank you. So now the concluding remarks of the reporter, 2 minutes.
Okay, I will report from Team Andromeda, and here is the concluding remarks for the problem number 15 volleyball. So first of all, I'd like to clarify how I conduct the experiment is that we control the ball at a single angle, and we just release it, and after the ball strikes on the ball, and we will quickly hold the ball to prevent it to strike the second time. Okay, so first in the short time, the opponent asks me why is there no error bar in the experiment data? The reason is that I have done many experiments, but I always get the same result. So I think the reason why there is no error bar is because I also have controlled the ball striking angle so that the striking force is always the same. And I also make a mark on the ball and make sure that the water surface is at the same position every time. And then in the discussion time, we discussed how do I know the trend for the 3 dimension since that there is no formula for it. The reason I put is because I want to explain why the water level, the water value increase, the frequency will decrease. And I think it's not an important part of my experiment because my main focus is on the causing of the wailing sound and also how does relative parameters affect it. So I think that's not the point. And next, the reviewer asked whether I have investigated the motion of the water. I think we should focus on wailing sound and relative parameters that will affect the result, such as water level. So that's all for my concluding remark. Thank you.
Thank you. So, 3 representatives, please stand up and answer questions from the jury. Are there any questions from jury? Okay, Li Lao Sư.
I have a question for report tracks. Will you go to page 20?
Page 20.
Sorry, just waiting for.
Like we have the figure about the frequency and the shaping frequency.
Yes.
20. Yes.
And yes, I can understand it's
not a little bit. Okay, so in my experience,
You label that it's a great shaking frequency.
because the way that I change the shaking frequency is that we put on the earphone and we hear the metronome at different shaking frequency. And we found that the shaking frequency is the same as rolling frequency. So I think it's the first coverage.
So that's a real number.
Yes.
So very nice.
Yes.
Okay. Other questions from jury? 钟老师 question for the
Reporter,
reporter.
how to get your graffiti? Because graffiti like email,
You need this blue one.
but 2 point, arrow bar.
Oh,
And
because
graffiti in this, I think should be fun.
I know what you mean. Is because the way I know the frequency of the whale sound is that we define it as a wave. Right? So the way that I know the whaling frequency of it is that we use checker to calculate each period of it and turn it into the frequency. So I think there because each I do many measurements of each one. All of them are similar, but not always just the same. So that's why there is an error.
Any questions from 陈老师、周老师？ So I have a basic question. In reporter experiment, I understand your variable. You have a water volume and have frequency. I noticed you have the energy. So I have a question for the opponent and the reviewer. What do you think about this energy? What kind of energy reporter is talking about? You want to answer?
I think it used the pendulum to strike the ball and about the collision.
And the energy, this is what energy?
And about the ball strike and cuts and the collect with the ball.
Oh, thank you.
But
What kind of energy do you think
yeah,
she's talking about?
I think the energy she's talking about is the kinetic energy of the water, because the water will be shaking and maybe the water will go up and down, and I think this is the main reason.
So you think she's talking about the kinetic energy of the water.
Yes.
Now, reporter, could you clarify the definition of your energy?
I want to know your meaning of energy is like I say that.
Yeah, what do you mean the energy?
Oh, because if we put the pendulum like that, so it will have potential energy, and if we release it, it will transfer to the kinetic energy and strike on the ball, so it will cause sound. And the reason why I have mentioned the energy here is because I want to explain why when the shaking frequency is too low, the whaling sound is not obvious.
Her definition is the potential energy pendulum transfers to the kinetic energy of the water. Okay, thank you very much. So please sit down. So now is the grading for the jury. Now the grade for the reporter. Six, 7, 6. Now the grade for the opponent. 6, 7, 6, 6, 4. 4. 7. Okay, the final is 4. Okay. And the score for the reviewer. 6, 8, 7, 8, 6. Okay, double check is correct. Okay, so any other comments from the jury? So now we close the round 1 and take a 10 minutes break, and please change your position.